Hey you guys, we're in chapter 11, section 2, and we're going to look at the surface area of prisms and cylinders. Now, our first objective says, I can name the parts of a prism. Well, that just has to do with vocabulary. So our next slide is going to be about vocab, and we just need to learn those names. The next objective says, I can use a net to find the surface area of a prism. Now, I sketched out a net the other day, and we'll look more at that on Thursday also. I can use formulas to find the surface area of a prism. Well, that's pretty easy. That's just a formula. So as long as you have the formula memorized, then we'll be able to just plug things in and you'll be able to use that formula. That's another thing you'll want to check on your reference sheet and make sure you have that formula there. And if not, then you know you need to memorize that for the end of course. And our last objective says I can find surface area and lateral area of a cylinder. Now, cylinder and prism, these are two words that we used the other day in class, and maybe you didn't quite understand their meanings or the definition of it, so you'll want to make sure you do after this lesson. Alright, so let's check out this vocab, and realize you're probably going to need to pause this when I'm finished talking so you can write down all of the vocab. The first word is prism. Now, a prism is a type of polyhedron with two congruent parallel faces. And we have two pictures over here of prisms. Notice it says that it has two, so exactly two, congruent parallel faces. Now before we said all of the sides were considered faces. So the faces though that are parallel to each other, we call those bases. So what we call the two parallel faces in a prism, we're going to call those bases. So we can differentiate them from all the other faces. The lateral faces are going to be what we call the faces of a prism that are not the bases. So the bases are the parallel ones, and then all the other sides are just lateral faces. Altitude. That's a perpendicular segment that joins the planes of the bases. So altitude, it's going to go from one base down to the other base. It's a perpendicular segment. So it's going to create that 90-degree angle. Height. The length of the altitude. So height and altitude, they refer to each other. If I want to know the height, I just look to the altitude and I find that length. A right prism. A right prism is the lateral faces that are at 90 degrees to the base. So it's a right prism if the lateral faces are at a 90 degrees to the base. So look below, we have these right prisms and we have these oblique prisms. Notice here that from base to base, it's exactly 90 degrees. And same thing over here, from here's the base on the side and here's the base on the side, and it creates 90 degrees. So your altitude, even though it refers to the height, sometimes your shape could be on its side, and so the height looks horizontal versus the vertical. So oblique prism, it's when the lateral faces are not rectangles or not 90 degrees. And here's our oblique prisms over here. Notice that when we drop the altitude to go make a 90-degree angle, it's outside of the shape here. If you dropped it from this corner, it would be inside of the shape, but either way, it's not straight down. Like you couldn't follow this segment down to create that 90-degree angle. All right, moving on. All right, so now let's talk about lateral area. We're going to call it LA for short. So the lateral area refers to the sum of the areas of the lateral faces. So for this picture below, we have our faces, the top and the bottom. And then we have, oh, I'm sorry, that's not our bases. Our bases are the sides here. And we know these are our bases because these are the only two that look alike. All our sides all around, those are all congruent to each other. So these are our bases here, and these are all our lateral faces. So our lateral area refers to the sum of the areas of the lateral faces. And we find that by taking the product of the perimeter of the base and the height of the prism. So I don't really like this picture we got here. It doesn't really follow along with my color codes, So kind of just ignore the color codes going on. Always you can find the bases because there's only going to be 2 of them that are congruent to each other. So at first when I initially thought the top and the bottom were the bases, I knew right away they weren't, since the sides are also congruent to the top and the bottom. And I know there can only be 2 congruent and parallel bases. So I knew that my sides were the bases here. Okay, moving on though. Surface area. This is the sum of the lateral area and the area of the 2 bases. So the surface area, again, it's the sum of our lateral area, and then we add that to the area of our base times 2. So LA stands for lateral area, and B stands for bases. And again, it's the area of the bases. So let me just write that out. Let me just say area of bases. All right, so make sure you have these formulas written down and let's move forward. All right, so for the 2 problems below, our directions are to use formulas to find the surface area of a prism. So our directions are to find surface area of a prism. All right, and we have these steps listed out for you. So it's great to write these steps down, so anytime you're asked to find the surface area, you can just use these steps. So step 1 says find the perimeter of the base. So first you have to identify what your base is. So in my example here, I can clearly see that the only 2 congruent parallel sides, or the only 2 congruent parallel faces, are these triangles. So these are my bases here. So I need to find the perimeter of the base. So it's a triangle. You see it's a 90-degree triangle, and the perimeter is just adding up all the sides. So we need to know what this last side is. This is our hypotenuse here. So you can always use a Pythagorean theorem with a right triangle. So we have 3 squared plus 4 squared is equal to, and our hypotenuse, right? So hypotenuse squared. So 3 squared is 9, 4 squared is 16. When you add those up, we get 25. So 25 is equal to our hypotenuse squared. And to figure out what h is, we're just going to take the square root of each side. So our answer is 5. And you should have already known that anyways, because 3, 4, 5 is one of our Pythagorean triples. It's one of the most common. Okay, so anyways, our perimeter, so P for perimeter, is equal to 3 plus 4 plus 5. So our perimeter is equal to 12 centimeters. Our step 2 says, find the lateral area of the prism. Well, we know for lateral area, that's equal to the product of the perimeter times the height. So perimeter times height. Well, we know our perimeter was 12 centimeters. And we're multiplying this by our height, which is 6 centimeters. It's given in the picture. So 12 times 6 is 72 centimeters squared. Step 3 says, find the area of the base. And let me number these steps. This was step 1, this was step 2. So step 3, find the area of the base. Well, our base is a triangle, and the area of a triangle, that formula, is 1/2 base times height. So filling this in, we know the base here is 4, so 1/2 times 4, and the height is 3. So 1/2, 4 times 3, 4 times 3 is 12, and half of that is 6. And this is going to be 6 centimeters squared. Step 4 says to find the surface area of the prism. And we have a formula for that. In fact, we just found everything that we needed for that formula. Surface area is equal to the sum of the lateral area and twice the perimeter of the bases, or the area of the bases. So now we can just plug everything in. So our lateral area was 72 centimeters squared plus twice the area of the bases. The bases is 6 centimeters squared. And we just multiply 2 times 6 and then add it to 72. So we get for our surface area 84 centimeters squared. And finally, this is our answer. Woo! All right, so all our steps, those were geared just so we could finally use the formula that we wanted to, which was our surface area formula, because that's the one we need. But you have to realize, in order to use your surface area formula, you need to find your lateral area. In order to use your lateral area formula, you need to find the perimeter of the base. In order to find the perimeter of the base, you need to find all the sides of the base. Also, to use the surface area, you have to find the area of the base. So that was step 3. So all these steps, they're not needless. They're all there for a reason, because in the surface area, there's other things you need to determine before you can use that formula. All right, so your turn. You try. Here's your shape over here. All right, so now there's just a few more vocab words. Well, we were talking about prisms before, and prisms have 2 congruent parallel bases. But when they have 2 congruent parallel bases that are circles, we call these cylinders. Now, a right cylinder is when we have the wall of a cylinder that's perpendicular to the base. And then an oblique cylinder is when the wall of the cylinder is slanted compared to the bases. So pretty much the same thing for a right prism and an oblique prism. Those definitions are going to follow along for right cylinder and oblique cylinders. For most pictures, you can just assume that the cylinder is a right cylinder unless it's stated in the problem or unless it's stated in the picture otherwise. So unless it's stated, just assume that you're always working with a right cylinder. Now, to use the lateral area formula for a cylinder, remember lateral area is equal to the product of the perimeter of the bases times the height. Well, height shouldn't be difficult to determine, but perimeter of the bases, our bases here are going to be circles. So when you talk about the perimeter of the circle, you're really talking about the circumference of a circle. So circumference of a circle is found by either 2 pi r or just by pi times diameter. Then when we're talking about the surface area, that's the sum of our lateral area plus twice the area of the base. And when we're talking about area of our bases, again, it's the area of a circle, and area of a circle is found by pi r squared. Our r here stands for radius. So you want to make sure that you know these 2 formulas, circumference, area of a circle, and I'm pretty sure these both are listed on your reference sheet, but you should double check just to make sure. Alright, here are the last 2 problems. Our directions are to find the surface area of each cylinder in terms of pi. So when it says something like in terms of pi or in terms of whatever, it means leave that in your answer. So we're going to leave this symbol pi in our answer. We're not going to plug in 3.14, or we're not going to push that pi button in our calculator. Okay, so our steps again. First, we need to find the perimeter of the base. So our bases here are circles. Perimeter of the base, and this is step 1. Let me label it. The perimeter of a circle, again, refers back to our circumference. So it's 2 pi r. So 2 times pi times r. And r here is represented with 2. Our radius is a 2. That's what the picture shows. So our perimeter is 4 pi. our next step, step 2, is to find the lateral area of the prism. And our lateral area is found by the product of the perimeter of the base times the height. Well, we found our perimeter, our circumference here is 4 pi, and our height given in the picture is 8. So 4 pi times 8 is 32 pi. Step 3, our third step is to find the area of a base. So the area of a circle here, we use the formula pi r squared. So pi and then radius is 2 squared. 2 squared is 4, so our area is 4 pi. Interesting, just like our perimeter, that's not always going to happen. We just got lucky here because 2 times 2 is 4 and 2 squared is also 4. So don't think that's always going to happen. And our last step is to find the surface area. So our surface area formula that we want to use is going to be our lateral area. So surface area is equal to our lateral area plus twice the area of the base. So our lateral area was 32 pi plus twice the area of our bases. We found it to be 4 pi. So 32 pi plus 8 pi, our answer is going to be 40 pi centimeters squared. And all I did here to get this answer was I followed those 4 steps from before. So make sure you go back to your 4 steps and you find first the perimeter of the base, then you find the lateral area, then you find the area of a base, and then you use all of that to find the surface area. So your last problem, you try. Here's your picture over here. Don't let it confuse you since it's on its side. Our bases are still the circles. And the 7, it looks like it's referring to the whole thing, you guys. So 7 is our diameter here. So don't let it trick you. Radius is just half your diameter. All right, you guys, see you in class. Bye.